Hi, my name is Francis Smart. I am here to present to you a Julia package which we've developed called BlockDates. It's a context-aware fuzzy date matching solution. This work is done in collaboration with Amanda Lemons and Allison Fishman at the Bureau of Transportation Statistics. I was formerly at the Bureau of Transportation Statistics as an ORISE fellow. I'm now with the Sensio Consulting Group. The problem statement or the problem that we dealt with at the Bureau of Transportation Statistics is that we received a large volume of reports that were reported to us on a weekly basis. We needed to parse those reports into daily records, which could then be used for subsequent analysis, both by human and machine. These dates did not come to us in a very consistent manner, and this text did not come to us in a very consistent manner. The dates within it could be either singletons or they could be ranges. Existing tools did not provide a solution for interpreting and extracting the dates, both for singletons as well as for ranges. With respect to the specific uses at the Bureau of Transportation Statistics, we receive weekly activity logs, which are reported within those logs on a daily basis. They have safety reports as well as level of activity. The Bureau of Transportation Statistics requires the capacity to parse these logs into daily records. Daily records allow for more precise measurement of event frequency and time-based trends, as well as error checking and checking for data completeness. We would hope that there'd be a broader potential for this tool to be used in other federal agencies which receive similar types of data, as well as perhaps in the wider spheres, such as medical use, in which or medical reporting, in which data might be reported by recipients of medical treatment on some kind of a log, rather than in a very freehand log, rather than in a more structured format, which would be obviously ideal to reduce the need for such a tool. Overall, BlockDates is a context-aware matching tool, as it looks within the context of the block of text and the potential date matches in order to find the best potential match. BlockDates uses Julia, which is an open source software package. It's a high-level programming package with rapid processing speeds due to its just-in-time compiling. And Julia was an excellent solution for us. It cut down the processing time of interpreting these blocks from as much as 24 hours for a single run to half an hour to 20 minutes. The particular structure of our data is such that we have both a start and end date, and we have a block of text. And within that block of text are embedded dates and associated text within those dates. In addition to the dates, we also have some error in how the dates are inputted. That is that they're inputted by hand, and thus we have a fair bit of human error which pops up, and BlockDates is able to correct for some of that error as well. The output is going to be output on a daily record basis, and it'll have the date, the text associated with that date, some notes where how it was interpreted, as well as a score. This is a little flow chart of how this works. So we have a start date, an end date on the input, and we have a text block. We can see that we have two different dates in our example text block, the 18th of March 2022 and the 19th of March 2021, which it's highlighted in red that 2021 is probably not the correct date. That was probably just human error. March is less likely for this to happen, but this is much more likely to happen around February or January of a new year, when people have not entirely adjusted to the new year in their brains when they're writing things down. We can see that this input is passed to BlockDates. BlockDates then parses it into a data frame with multiple rows, in this case 2 rows, assigns a score to each of the rows. The daily record is it receives a score, and then any modifiers, as anything that the BlockDates had to use above and beyond to correct the date. In this case, and on the 19th of March, it added an additional year to the date and assumed that the user meant to put in 2022 because that was within the viable range, and ding the score just a little bit because that's an easy correction. The overall score is 4.5, and the max score is 5, so it's a pretty good score for the overall block. We can see that the dates are sorry. So this shows the flow of how BlockDates flows through the dates. Yeah. This slide shows how the BlockDates package processes the inputs and returns the best match. It prioritizes the matching of ranges above that, the matching of singletons. That is because anything which is a viable range match will also be a viable singleton match. The flow is basically, we're splitting line by line, we're standardizing the date, we're moving basic notation like commas, spaces, dashes, periods. We're moving days of the week. We're moving connectors and converting to a common standard. And then we're going to attempt to match a range and within the date, and then we apply the range, see what pops up, and then we attempt to match singletons within that. And so we're going to loop through each of the singletons within each of the ranges, and in the event that we get a score of 5, that is that there's a perfect unambiguous match, then the algorithm stops immediately and returns the best match. Otherwise, it's going to loop through every potential option. I believe that there's about 10 different potential singleton matches and about 12 different range matches. So it tries quite a few and then is going to only return the best one. How the scoring happens, we basically prioritize unambiguous formatting, sequential ordering, complete coverage, that is, all of our dates are covered within the range. We penalize dates which are out of range. We penalize anything where we have to correct a year. So in this case, you can see +1 year, or someone transposed 2022 or 2202 for 2022. In which case, you have to subtract 180 years, so that's also penalized. If a duplicate date appears in our data, that is penalized. Usually the reason for there to be a duplicate date within a block of text is because someone's making a note or making a correction or making a change to the previous data entry, in which case it is appropriate that it's flagged for review. And then we also mark if there is a range. So since ranges are not that common, we will report when a range is found, and we call it range found. Pretty straightforward. When we're thinking about building a system like a fuzzy match system, basically the trade-off is between a solution which is too flexible and one which is too rigid. And we're trying to find the sweet spot in between. So if it's too flexible, then we're going to grab things which aren't date and pulling them into our data, interpreting them as date, and then the human reviewer afterwards has to parse them out. If we're being too rigid, then we're going to exclude potential dates, which are actually reasonable matches. So in this case, these are 2 example narratives of someone doing traveling, visiting ruins, went walking, found a coin 3/4 of an inch in diameter, and on the next day they continue traveling. So if we're being too flexible, then we might find that 3/4 is a reasonable match for the date, and thus we might actually end up falsely attributing a date to that, and we would get this message if we did. However, in the next block, we're being too rigid because we have a year, no year, and a year. And this is just probably human error, human inconsistency. So if we're being too rigid, we require the year. We assign this whole block to the 10th of August, and the next block is filled as missing, basically, and the next day is correctly assigned as well. So that's the basic trade-off. The algorithm has some features by evaluating between score of what things are allowed and what things are not. However, with any of these things, there's always going to be some issue as to what can be allowed and what can't be allowed. And sometimes there's a possibility that things which aren't dates are interpreted, or things which should be dates fail to be interpreted. Within our application to Bureau of Transportation Statistics data, we have a sample of 59,000 narrative records that include dates within those records. 96.5% of those, when passed through BlockDates, returned a positive score, and upon human review, we're highly confident that those dates are valid. Among the 3.5% of records which did not have a positive score, 78% of them were correctly recognized as having no viable date matches. Sometimes people submitted records which were more or less placeholders, or records which were not meant to be interpreted as real data records. And then, so we have about 22% which did not, fail to match the correct 22% of 3.5%. So it's a pretty small amount which failed to match, and those would have to be manually reviewed. As far as the next steps with regard to Julia, we need to do the full public registration. The process involves additional expansion of testing to cover all the features. It's about 60% covered right now. Additional documentation to cover all the functions on all the parameters, and then some kind of tutorial or handbook would be helpful as well to include to get people started on it. You can contact us at, for instance, smart at sensioconsulting.com, Allison Fishman, allison.fishman@dot.gov, or Amanda Lemons at amanda.lemons@dot.gov. With regards to actually how this works, I have a small demo prepared, and it shows an example of, basically, we have a start date, we have an end date, and we have a text remark. So this is an example of a range. Here's the ID2 is an example of a series of singletons. This will be read into a CVS file, or CSV file. This will be read from a CSV file with a CSV package. This example looks like it's read properly. You can see the dashed ends are for line breaks. We have to do a small bit of conversion. We need to convert the date from string dates to date formatted dates, just because they weren't picked up. Remember, we have start dates and end dates input into our data. And then we basically loop through each row of our input data. In each row, it generates its df temp, basically a temporary data frame, which will be appended to df out. And you'll get an ID basically based on each row. And we can see what df out looks like. So we can see that the ID1, which was the range, is spread across 7 observations. So it's spread across the entire week from the 22nd to the 28th. The score is 5, so it was well scored. It recognized that this was an unambiguous date. Range, there's range found. With respect to ID2, we had a series of singletons. So we can see that the 5th through the 11th, so we have a complete coverage of the entire week. We got a score of 5 again. And and then that output can then be saved into a CSV file, which can be then read by Excel or some other data analytics process. which was very useful for our purposes. I hope. I'll flip back to contact information. Overall, I think the package has served a very niche and specific purpose, which has been saved quite a bit of time as previous procedures which we had developed and had implemented in the past, and were not able to accommodate the full range of the data that comes in. Of course, as new data comes in and new problems present themselves, the data will have to add additional formatting or packages, formatting structures to the package to adjust for potential inconsistencies, which we've not yet anticipated. This is probably going to be the case with all data, as unless our reporters get much better at being consistent. Thank you very much for your time.